Hello, hello. Let's see. Hold on. Hi, everybody. It is April 10th, 2022. It is a blustery day here in North Carolina. I'm surprised it was warm all weekend and now it's freezing today. But my name is Whitney Whit. I am a GMAT, Jerry, and EA instructor here at Manhattan Prep. And tonight's GMAT Prep Hour is going to be about data sufficiency, and the two, as I think of it, the two most important techniques needed for data sufficiency. So tonight we'll be talking about rephrasing and testing cases on increasingly difficult problems. Yeah. So all you'll need is pen and paper, or if you got your yellow pad and want to use your pen and yellow pad or whiteboard, that's cool too. But let's do this. Let's jump in. So just a quick intro to the quant side of the GMAT. I figured it'd be nice to just sort of take a look. That within the quant section, we have two different question types. We've got problem solving and we've got data sufficiency. And so they make up each about 50% of the quant section. You've probably seen this in other free prep hours or in your studies already. So problem solving does technically make up a little bit more of the test than data sufficiency, but not by much. If you're working on 1x or what we might call standard time, your average time per question will be about 2 minutes, or precisely 2 minutes per question. You've got 31 questions in 62 minutes. Take that number up if you have 1.5x or 2x accommodation. Tonight, I will be working on the standard 1x timing. And so the timers I'll be putting on screen, you'll see fit for that. A little bit about me: when I'm practicing something new, I like to use timers that count up so I can get a sense of how long something takes, and then I work for as long as it takes to get an answer. And so tonight, obviously, we're in a group, so I'll cut us off. But if you want and you're watching this recording, you can always hit pause and start your own timer and work for as long as you'd like. Yeah. Cool. So a little bit about data sufficiency, because that's the weird one. That's the one that people aren't always, or unless you've studied the test, are not at all familiar with. Data sufficiency will have, let's call it 3 basic pieces. So the first piece is the question itself. So going forward, I'm just going to call this the question stem. And so the question stem is sometimes literally just a question, like what is X? In this case, at a work conference, how many of the employees are senior managers? So often it's just a question, but there may be content given. There may be some facts or additional information given in the question that we'll need to solve. So if we think about problem solving, so good old-fashioned multiple choice, if we think about problem solving as what we're accustomed to in math questions, they give us a bunch of information, we get a bunch of facts, and then they ask us a question, we solve, and an answer spits out. Data sufficiency is sort of the opposite of that we get the question up front, and then all the information follows, right? So we get our question up front, and then that question is followed by 2 statements. These will always be the same. I mean, there will always be 2. What they say and then will not always be the same. But there will always be 2 statements. Now, a little bit about the statements, just to make sure that we're clear, but this will come back up. Statements are always true. Always true. So another way to think about that is that they are facts. They are trying to help. And they won't disagree with each other if they, or let's say they won't be in opposition of one another, but they themselves won't disagree with one another. I'll just leave it as that. We'll see some kind of weirder examples of it, but they will not disagree with one another. And I say this because the way data sufficiency works is that I'm trying to answer a question. I'm not trying to evaluate if the facts they gave me were true. So again, if we think of a standard problem solving multiple choice, when you go to answer the question in multiple choice, you're not asking whether all the information they had given you was true. You're just figuring out how to use it. right? A problem tells you some information. So we'll give a little example, right? So let's say a good old-fashioned multiple choice problem says if x plus y equals 32 and x minus y equals 10, then what is the value of x? Question mark. And then some answer choices. ... 5 of them. So let's take just a minute. I want you to answer this question for me. If x plus y is 32 and x minus y is 10, what's the value of x? And if you haven't, go ahead and get me your answer in the chat window. We're going to use some systems of equations. So we use some algebra for this. If x plus y equals 32 and x minus y equals 10, we have a couple of options. We could use substitution, where you simplify one of the equations and plug it in. Or you could use stack and add, elimination. And so that's what I'm going to do in this case. I'm going to just make this x plus y equals 32 over x minus y equals 10, right? 2x equals 42. And so if I divide through, x equals 21. Nice. So I promise this isn't a lesson on basic math, not exactly. But notice that at no point did I or you question whether x plus y was 32 or whether x minus y was 10. I didn't ask, I just used the information. And I used it to try and get an answer to my question. Okay, so now let's take the same thing, but let's rearrange it a little bit. Yeah, so now I'm going to say, let's do it this way. What is the value of x? And this time, instead of answer choices A and B, I'll start with statement 1, x plus y is 32, and statement 2, x minus y is 10. It's the exact same. This time I gave you the question first. I gave you the two pieces of information, second and third. Now, our job for data sufficiency is to try and answer the question. But it's a little different. This time, there aren't going to be answers on the page the way we're accustomed. This time, the answers will still be there. We'll have A through E, but they'll be given in a weird format. So if we look, let me put them here for you so you can see them. So these are data sufficiency answer choices, right? So we have a question up front. We're then given two facts, but instead of solving for the value of x, so, okay, well, given statement 1, statement 2, x equals 21, we're actually asked something different. We're asked whether the information in each statement is enough to answer my question. And so for problem solving, right, for our friends, the multiple choice question, I'm going to use all the information I've been given, all of it, no matter what. When it comes to data sufficiency, I'm only going to use as much information as needed, and then I'm going to stop. So if I don't have to use all of the information, then I won't. I will use only what I need. So in this case, what is the value of X? I'm going to go through each statement one at a time, each fact one at a time, and figure out, is that fact all by itself enough for me to answer the question? So I want to know the value of X. And all I know is that X plus Y equals 32. Well, X could be all kinds of stuff. X could be 10, and that would make Y 22. X could be 20, and that would make Y 12. X could be 30, that would make Y 2. And then that's just assuming integers. There's, an infinite number of non-integers, and we got negative numbers and all over the place. So this is going to be what we call not sufficient. It is not enough information to answer the question. And so I didn't ask, or I didn't state whether the statement was true or false. The statement is a fact. Just like they would be in problem solving, it's a fact. What I am trying to figure out is it enough? Does it give me enough information? And in this case, it would be no, it does not. And so I mark that on my paper, and we'll look at how to kind of organize as not sufficient. Now, if I look at my answer choices, all of my answer choices are asking this language of sufficient. Is something enough? Is it sufficient to answer the question? Turns out that in this case, statement one is not sufficient. And so because statement one is not sufficient, I'm going to eliminate any answer choices that say that. So answer choice A says statement one alone is sufficient. That is false. So I will eliminate answer choice A. Right? So just keeping note. And then each statement alone is sufficient. That would mean that both, right? Like statement one is sufficient and statement two are sufficient. And that's not true here. Statement one is not sufficient. And so I would eliminate answer choice D. And that's going to leave me with B, C, and E. So I'm drawing on the board what we call an elimination grid. So an elimination grid is where we organize like answer choices in two lines based on whether a statement is or is not sufficient. And so this is what we'll call a statement one grid. Okay, what that means is that based on me looking at statement one first, so I got to it before I got to statement two, I'm going to write this on my paper. AD and then BCE, because AD are the two answer choices where statement one alone is sufficient. BCE are the answer choices where statement one alone is not sufficient. Statement one alone is not sufficient, so I want to get rid of this A line. So now I'm on the B line, which means I should go to statement two. Once again, to know that the difference between two numbers is 10 doesn't tell me what one of those numbers is. They could be 20 and 10, 30 and 20, 40, right? And so on and so on and so on. And so this one is also not sufficient. At this point on my grid, right? So my first statement is going to get rid of the most. Based only on my first statement, I'm going to be able to get rid of 2 or 3 answer choices quickly. Yeah. And so a line will go through either 2 or 3. Once I move to the second statement, we're now just going one answer at a time. So statement 2, not sufficient. I'm going to eliminate B. And now if I put the statements together, we already know that it's 2 equations, 2 unknowns. We solved it already. And so sufficient. So 1 plus 2, now that I finally put them together, is in fact sufficient. I didn't need to do the solving. I didn't need to get to the point where I saw that X was equal to 21. It was enough in this case to say, I understand mathematically that I will get an answer. And so since the two together are sufficient, I'm going to pick C. Notice that C, both the statements together are sufficient, but neither alone. Okay, so that's the key to C, is that I'm not going to move to C unless I have to. So that's why my little grid's going to be kind of nice here. Yeah. So let's try another. And I'd like to think of this in terms of, kind of getting myself organized and not really fighting with the facts. So we'll go back to that very first one that I had on the screen for us. And we'll do this one. Our time, about 2 minutes. I don't think it'll take that long for this one, but we'll take about 1.5 minutes. I want to know, what is the correct answer letter? I don't care what the actual numeric answer is. Awesome. If you haven't given me an answer yet, go ahead and do so. That's about 2 minutes. On average, you'll want 2 minutes. You could take as long as 3 minutes occasionally, or you might take as little as 1 minute. I would say in general, because the test is adaptive, you'll be working up against your limit. And so, like, ability wise. And so, only spending 30 or 45 seconds often means that we're rushing and making potentially careless mistakes. Yeah. So just know that we're trying to stay in that neighborhood of 2 minutes. Nicely done for everybody in the room who answered. So up front, we have a question stem. How many of the employees in attendance were senior managers? And then of the employees in attendance, right? Like now we're getting some individual information. So a little bit about this, what I would like for us to talk about before we jump into the actual techniques for the evening are how to organize our page. Yeah. And so in terms of organizing the page, I'm a big fan of what we call a T-chart. And so the way the T-chart will work, let me get you one on the board so it's easier to see. It'll make life a whole lot easier. There you go. So a T-chart would mean that you're going to put information from the question stem at the top. And then we'll literally break the information that we're talking about for each statement. We'll break them into like 2 different areas under a T line. Yeah. And so it'll give us some space to do some manipulation or simplification and so on. There we go. Oh, and it would help if I actually had it on the screen so that you could see it. Yeah. Okay. So if we put this question up as a T, it might look something like the following. So we're going to put our own information in and around it. So my steps, the way I move through all data sufficiency questions is as follows. I will start on the top of my T. So if this is my little generic T, I'll start on the top left with facts. I will then write my question. I'll be very specific about it. And then I might rephrase, meaning translate a little bit. And that's one of our big steps tonight is to rephrase. From there, I'll make a kind of assessment about what type of question it is. We'll do that in a second. And then I'll decide which statement am I going to start with. Based on that, I might write down a little ADBCE, which I'll do for this one. So I'm going to go ahead and start with statement 1, so that won't be such a big deal. No upfront facts given at the conference, how many were senior managers, so no facts. But I do have a question. My question is, how many senior managers? And I'll put a little question mark. I always put a Q with a big box around it so I know which part is the question and what part has like the extra information. And then again, I'm going to start with statement 1, so I'll write down ADBCE. Now, one more thing we need to know. There are technically 2 types of questions in the world of data sufficiency, roughly 2 types of questions. There are value questions, and so that would be a question such as this one that's asking for a value. And then there are also yes, no. So we'll see one of those in just a second. But value means I'm looking for a single specific value. And I'll often note that on my paper with like a V with a circle around it so that I know that the answer I want is a number. Statement 1, of the employees who attended the conference, so 80% of the total, so I might write this algebraically as 80% of the total are senior managers. Now, variables don't have to be a single letter. Variables can be words. So I would caution you against going back to your 7th and 8th grade, 12-year-old and 13-year-old math, where you turn everything into an X and a Y, because X and Y aren't always intuitive. In this case, I might be thinking of senior managers as the letter S. My S's turn into 5s, so I have to be very specific about how I write them. So for this, I might just write 80% of the total equals senior managers. I'm not trying to write a bunch of equations yet. If I have to, maybe, but for now, just using some partial words, that shorthand is great. So knowing that 80% of the total are senior managers, that doesn't really tell me how many are senior managers. If I had 100 total people, that'd be 80 senior managers. If I had 200 people, that'd be 160 senior managers. If I had 10 people, that would be 8 senior managers. So I don't know. I just ran through a few cases, right? I tested a few cases. And so I got not sufficient. Now, again, I tested out cases. You might also say, this is essentially an equation with two variables. So how am I supposed to know? Right? I don't know. So you could use the algebra if you felt comfortable. So statement one, not sufficient. I'll eliminate A and D. Move to statement two. Of the employees who attended a conference, so again, total, 64 were not senior managers. Okay. So this time it's a number. 64 were not senior. So I'm just going to write not. So 64 were not what I wanted. That certainly does not give me information about the senior managers. And so I will eliminate. Once I'm there, if I need to, I will then draw another line. And down here is where I will do the statements 1 and 2 together. So I can bring that information down. So here's what I know. I know that 80% of the total would be senior managers, which then by extension means that 20% are not senior managers. Because it wasn't like they gave me senior and junior, because then there might have been other types of managers or people. They gave me senior managers and not senior managers. So that's one or the other. Everything in the world is a rock or not a rock. Like I'm not a rock and you're not a rock and my computer's not a rock, right? So senior manager versus not senior manager means everybody. So if 80% were, 20% were not. Now I'm going to, not so algebraically, kind of make a note that 20% is equal to 64. 20% of the total, which means I could come up with the total. It also means that if I wanted to, I could come up with 80% by multiplying my 20% by 4. So whatever the heck 64 times 4 is, that would give me a number right here, which is what I want. I want the number associated with 80%. And so together, sufficient. Once again, our correct answer is C. Awesome. So here we are in a space where we're dealing with, right, like the big picture. What I'd like to do now is look at my favorite skill, which is the skill of rephrasing. Okay, so let's go with a skill of rephrasing with this problem. I'll set a timer for you. All right, if you've not given me an answer yet, do. Okay, very nice. So a little trickier, right? A little trickier. Often what will happen at this point on questions is that people start to get a little panicked and they want to start picking numbers. And even more than that, they see how nice and simple these two statements look and jump immediately to those. Let me get to the statements. And here's the thing. I want to embrace my little T-chart, but what I really want to embrace is the fact that the top is and can be a pretty decent chunk of space, because I want to make sure that I've spent time rephrasing or rewording or simplifying or better understanding the question's stem. Yeah. So in this case, I see how much messier this question stem is than my statements. I'm going to leave a lot of room to work there. So I have been given some information. I know that X, Y, and Z are positive in their integers. So I've got X, Y, and Z are all greater than 0. They're also all integers. So I'd probably get it on my paper that way. And then I have a question. So first step is to rephrase the question from literal words into some kind of something on my page. And this one, it looks a lot like algebra to me because it sort of reads like an equation or an inequality in this case. So that's what I'll write. I'll write X plus Y times Z. And sorry, I should say, I will write this as the question that it is. I will ask, is X plus Y times Z, is that greater than Y plus Z times X? Now, in order to solve this, if it were an equation, the first thing I do is simplify by multiplying through. Let's see what happens when I distribute. So just keep imagining if I were trying to simplify this expression. So is XZ plus YZ greater than XY? I try to keep things alphabetical. XY plus XZ. Okay, no, is that bigger? I notice there's an XZ on both sides, so I'm going to subtract it from both sides. So my new question is YZ greater than XY. Now I have an inequality, so normally I'd need to be really careful with signs. So multiplying or dividing by unknowns flips my sign, because if it's negative, it would flip. You know, if it's positive, it wouldn't. So I kind of have to be really careful, except they told me that all my variables are positive. So I can multiply, divide, do whatever I want. They don't equal 0 and they aren't negative, so I'm fine. So I will divide both sides by Y. And now my final question is Z greater than X? So the power of the rephrase in this case, and so this is an example of a yes-no question. Is Z greater than X? Yes, it is. Is Z greater than X? No, it's not. Okay, so this is a yes-no question. They're just asking me for whether the answer is a yes or a no. And in this case, I take a look at my statements. I'm going to start with statement 2. Now, I'm still going to always organize statement 1 on the left and statement 2 on the right, no matter what. And so statement 2 gives me my answer. It answers the question, yes, Z is in fact greater than X, and I'd write sufficient. Now, I started with statement 2, not statement 1. So I want to use the correct elimination grid, and the elimination grid we did already, the AD, BCE, was for statement 1. I need the grid for statement 2. So my statement 2 grid is BDACE. So it's the same grid as before. Last time it was ADBCE. The only thing that changes when we switch out our grid is the letter up front. That's the only thing that changes. So BDACE. Right? And so statement 2 is sufficient. I get to get rid of all 3 of those answers, A, C, and E. All of them. Now I move to statement 1. Knowing that Y is bigger than X gives me no information about Z, because there's no upfront information. So knowing that Y is bigger than X doesn't tell me that Z is, and so not sufficient. My correct answer then is B. I'll stick with just B. Okay, so the importance of the rephrase. Often we have a lot of information in the question stem. I want you to spend some extra time there trying to clean it up, see if you can't get it to simplify, and so on. But that's not always possible. It is not always possible for us to simplify the upfront information through some form of algebra or numbers or plugging in or listing out. Sometimes the upfront information is pretty simple. It's still important that we get it onto our paper in a visually appealing and kind of powerful way, but we might not be doing any rephrasing. Our rephrasing might happen in the statements themselves. Yeah. So we'll look at what that might look like here when we think of a couple of different, right? We'll look at a couple of different types of rephrasing. So let's give this one a try, and I'll set a timer for you and send me your answer when you got it. All right, if you haven't done so, get me your answer. But this is yet again a problem where we haven't been given much upfront information. The fact is that x doesn't equal 0. And then my question is, once again, a yes, no. Is x equal to 1? There's not much to fix there. So I'll leave it at that. My two statements look kind of similar. So I'll mark my yes, no, and I'll write my ADBC. So step 1, we'll take a look, and I'll maybe do it in black so it's easier to see. Let's start with statement 1. Step 1, I'm going to try and rephrase. So I'd get this on my paper, but then I would try to rephrase it. I don't like variables in denominators if I can help it. And so in this case, it's an equals. So I can multiply by whatever I want. So I'll actually multiply both sides by x squared. So x squared to the left becomes x to the 4th. And then x squared times 1 over x squared just becomes 1. Now, anything raised to an even power, 2, 4, 6, 8, and so on, is going to be positive. And so if I see x to the 4th equals 1, in order to solve that, I'm going to take a 4th root in this case, which is kind of crazy. But I'll take a 4th root. And because it's an even power that I'm including, I need to put a plus or minus with that root. So what is the fourth root of 1? So in what number times itself 4 times would give me 1? Well, the fourth root of 1 is just 1. I just have to remember the plus minus from this former exponent term. So I have x is equal to plus or minus 1. So the answer in this case is maybe. It might be equal to 1. It is possible that x equals 1. It is also possible that x equals negative 1. 1 would give me a yes answer, but if it turned out that x was equal to negative 1, it would give me a no answer. Not sufficient. Start with my row that has an A and mark it out. I'll move to statement 2, and I'll do the same thing. So I'm going to multiply both sides by an x. So this is my rephrase in my statements. X cubed equals 1. This time I've got an odd power. So anything raised to an odd power would keep its sign. So negative 2 to the third power would be negative 8. But positive 2 to the third power would be positive 8. So if I've got something cubed and it equals 1, then it had to have started off as a positive thing. So the cubed root of both sides, taking odd powers, I don't need to apply the plus or minus. I only add the plus or minus when I draw an even power. So x, according to statement 2, x is actually equal to 1, which is in fact sufficient. And so my correct answer is B. So I'm still thinking about rephrasing even as I move down into my statements. Okay. What about, I'll give you your answers back. Let's try this one. All right. Nicely done, y'all. Very nicely done. This is actually a very tricky problem. There's not a great way to rephrase the question, in a way that you might simplify it, but it doesn't mean that we can't get a good visual. So for a problem such as this one, anytime they're listing out a set of numbers or giving me examples, I'll actually write those numbers down. So long as there's under, I don't know, let's call it like 12 or 15 numbers, I would write them all down. So I have been given a little bit of information. It's important that I note that X is an integer. I really want to pay attention when they tell me that a number is positive or an integer, because I don't want to assume it. So if they tell me, I want to kind of get excited about it. So is X in this list? And the way I would write it is maybe kind of like make it look a little bit like a set. So is X 20, 21, 22, 23, 24, 25, or 26? And once again, yes, no question. And my statements look the same, so I'll start with AD and then BCE. Statement 1, X is a multiple of 9. Yeah, there are some ways to visually translate this in terms of maybe writing it sort of like an equation, but that's not the most convenient. And if you want practice with that, there is a great free prep hour about divisibility and data sufficiency. And so check that one out. I think that's the one that Dimitri does, and it's super good. So X is a multiple of 9. What I'm going to do instead is I'm going to test out cases. So I'll start with what they give me. So my first column is usually the thing I'm going to pick for. I know X is an integer. I know it's a multiple of 9. And so I'll write like a little X and then underneath it kind of multiple of 9. And then I'll write one of them down, like 9. Now you might want to write a couple down just so you can get a sense of what that means. 9, 18, 27, 36, and so on. Multiples could also be negative numbers, and a multiple of 9 is also 0. So just keep that in mind. But they told me positive, or they told me it's an integer, and I'm really only caring about this upper end, so I don't really care. So I'll start with 9. The next thing I would do is ask my question. Now, there may be some other steps in the way, but right now it's just X a multiple of 9. I picked it. And now, how does that answer my question? Is X in the list? The answer is no. It is not in the list. What I'm looking for, right, is to see if I can prove not sufficient. So when we test cases, our goal for testing cases is to prove not sufficient. In other words, I've got a yes, no answer. Right? I've already got one. Put quotes around it just for, completeness. I've got a no answer. I'm looking for a yes answer, which would mean I need a value of X that is one of these so that I can say, yes, X is on that list. But if I start going up my multiples, 9, 18, 27, 36, they are all no. They're all no. They're all no. And so what happens? I keep getting the same answer. I don't care if the answer is yes or no. That part doesn't matter. I keep getting the same answer over and over again, and that is sufficient. Statement 1 is sufficient. I eliminate answer choices B, C, E. I would do the exact same thing with statement 2. X is a multiple of 3. I'd test a number like 3 and then ask my question. 3 is not in that list. However, if I jump up a little bit and pick something from the list like 21, I get a yes answer. And so I've now received 2 different answers. One possible value of X gave me a no answer. A different possible value of X gave me a yes answer. And so not sufficient. My correct answer is A. So sometimes we get kind of pushed into this place where we need to test cases. And that's our option. We need to sit down and test some cases. Beautiful. Okay. Let's try it again. Give this one a go. And again, your options are A, D, B, C, E for statement 1 first, or B, D, A, C, E for statement 2 first. right, if you haven't got me your answer, get it to me. So this is messy kind of all over the place, right? A little bit messy all over the place. Let's start up front. I'll make our little lines. Here we go. So I've been given some factual information. I was told, right, if this is true. So I'm going to write that on my paper, and then I'll write the question, what is the value of x? So x equals what? It's a value. Now I need to do some rephrasing with this. I need to do some simplifying. And sometimes rephrasing is through algebra. Sometimes rephrasing is through testing out cases. So in this case, I would kind of combine my terms on the right. 8x is greater than 7x. And then I'll subtract a 7x from both sides. And I get that x is greater than 0. So as long as x is greater than 0, I want to know what does x equal. Statement 1 probably looks a little nicer. So I'll start with that one, A, D, B, C, E. And now I'll do the same thing. I will add a 4x to both sides because I don't like a variable with a minus sign in front of it. Actually, I'll do something just to kind of show you the math for it. But let's say I subtract a 6 from both sides. I go old school and keep the 4x on the left. And so I got negative 4x is greater than negative 8. Now, when I divide both sides by negative 4, dividing by a negative or multiplying by a negative in an inequality flips my sign. So this would become x is less than 2. All right, so I know that x is less than 2 and greater than 0. And I didn't note it, but I should have. X is also an integer. So if x is an integer, less than 2 but greater than 0, then x has to equal 1. And so sufficient. I know the value. A hangs on, and so I'll get rid of BCE. In order to solve an inequality with multiple sides, I have to do the same thing to all 3 sides equivalently. So I don't like these 2x's on the end, but they match. So I'm going to add 2x to all parts. So I have to add it everywhere. And then let's just be really careful. This is 3 less than or equal to 4 minus x plus 2x is 4 plus x is less than or equal to 5. Now, at any point, if I had to multiply or divide by negative, I'd flip all the signs. So I'll subtract a 4 this time. I get negative 1 is less than or equal to x is less than or equal to positive 1. Now, I know that x has to be greater than 0, and it then has to be less than or equal to positive 1. And so, once again, I get that x equals 1. Sufficient. Now, note, I mentioned before that the 2 statements have to agree. If statement 1 had gotten down to a simple solution and I got, oh, okay, x equals 1. And I did some work for statement 2 and I got that the answer was x equals 3 or something like that, I did something wrong. Or I'm working from a bad source. But as long as I'm working from a fairly reputable source and not just like random questions on message boards, then if I got 2 different answers for my statements, but they were both sufficient, I've done something wrong. Okay. In this case, they are in fact both sufficient, and so I will pick answer choice D. Answer choice D. Okay. All right, let's try one more. Up the challenge, shall we? I'll let this one run all the way up to 3 if we need it. And again, A, D, B, C, E. If I start with statement 1, B, D, A, C, E. If I start with statement 2. All right. At 3 minutes, you'll want to have guessed. Tough, huh? This one's a little trickier. There's a lot happening with this one. So this is why it gets really important to start to practice things like testing cases, but also looking ahead at all of the pieces and deciding where you want to start. As best as I can tell, X is a multiple of 3 is a little bit more straightforward. So that's potentially the statement I'll start with. Upfront question, is X a multiple of 12? There's not really a lot to be sort of simplified here, but what I might say is X, and then start maybe listing out some. So on one end, multiples of 12 could be negative, like negative 36, negative 24, negative 12, 0, positive 12, positive 24, positive 36, and so on. So I'm a big fan of kind of listing what this might look like. So is X in that list? And I'm going to start with statement 2. So B, D, A, C, E. So we've got X a multiple of 9. I'm going to do my little multiple of 9, or excuse me, multiple of 3. X a multiple of 3. And I'll start with the first one is 3. I'll just make it 3. So X a multiple of 3 is X. So I'll make a note to my question and I'll ask it of myself. Is X a multiple of 12? 3 is not a multiple of 12. Multiples of 12 are 12 multiplied. So 12 times 1, or 12 times 2, or 12 times 3, or 12 times 0, or 12 times negative 1. And so the answer here is no. But is there a multiple of 3? So multiples of 3 would be 0, so that would work. But 3, 6, 9, 12, 15, 18, 3 multiplied times. And it turns out, yeah, 3 times 12, right? 12 is both a multiple of 3 and a multiple of 12. I get a yes answer, not sufficient. So B and D are out. This next one is not super pretty. Not super pretty. Now, here's the deal. I don't know anything about X, like at all. I know nothing about X at all. So what might be good is to rephrase it a little bit, like this statement, maybe algebraically rephrase it a little bit before I start just randomly trying to pick values of X. And so I'm going to write it, the square root of X minus 3. And I told you variables could be words. So X minus 3 is odd. So I'm just going to write odd as the number. To solve for X, I'll square both sides. So X minus 3 is going to be an odd number squared. And then I'll add a 3 to both sides. So X is equal to an odd number squared plus 3. Okay. So let's start listing out some possible X's. So I'm actually in this case going to just write down some odds. So an odd number like 1, 3, 5, 7, and 9. Honestly, that's probably more than enough. The test is not trying to make me pick a million numbers. Okay. So if the odd number I'm picking is 1, then what is X? Well, X would be 1 squared plus 3 is 4. How does that answer my question? It answers the question, no, X is not a multiple. 4 is not a multiple of 12. 3 squared would be 9 plus 3 is 12. Oh, well, there's a yes answer. All righty then. Very cool. So I get a not sufficient once again. And so A is out. And if I wanted to, at this stage, I'm going to try and put them together. But let's say I was stuck, no worries, right? I would guess C or E. I'm not sure which, but I would guess. So now let's put the two statements together. Okay, and I'll make a little bit of space for us. Here's what I know. I know, and I'll kind of build my one table up. I know that X has to be, and I'll do it the other way around, an odd number squared plus 3. That's going to be X. X is also a multiple of 3. So I also need, so this is one statement. This is statement 1, in fact. But statement 2, I have to verify that X is a multiple of 3. And then I'm going to ask the question, is it a multiple of 12? So as these become more complicated, and as I now have to incorporate both statements, I might get kind of a big, ugly table, which is fine. So if I look back at what worked, right, like I'll pick my, 3. I'm going to try and pick things that worked for both. X being 12 worked for both. So I'll start with the odd number 3 instead of writing down the odd number 1, but I'll start with the odd number is 3. So if the odd number is 3, then 3 squared, 9 plus 3, x is 12. X is a multiple of 3. That's true. Is x multiple of 12? Yes, it is. So I got a yes answer. All right, let me try some more. So this has to be an odd number. So I'll pick 5. 5 squared is 25 plus 3 is 28. That is not a multiple of 3, so I can't pick that one. Let's try 7. 7 squared is 49 plus 3 is 52. Right, 7 times 7 is 49 plus, is 52. And is 52 a multiple of 3? No, it's not. Ooh, not pretty. Right, and so, so is it a multiple of 3? Nope. And let's go one more. 9 squared, 9 times 9 is 81 plus 4, or plus 3 is 84. Now, if I add, to figure out if something is divisible by 3, I can just add up the digit. So 8 plus 4 is 12. That is divisible by 3. And then I'd ask, is 84 a multiple of 12? And it is. It's 12 times 7. I get a yes. The fact that I had to go so far to get one that works makes me think that this is probably sufficient. And so I'll put the two together. I'll call it sufficient. And then I'll choose answer choice C. And it is. All right. So if I start having to get to kind of big numbers, I know that I'm not going to have to go very far. So my correct answer is C. Right? So our goal for data sufficiency is to get ourselves started with 3 big skills. Right? Getting it onto your paper in a way that's clean and organized, so the T chart. Practicing rephrasing or simplifying as best as you can. And then being really organized as you test cases, trying to prove not sufficient, right? Trying to prove D if you can. Awesome. Well, first off, thank y'all so much for coming to hang out. We always appreciate it. You can always find us on our YouTube channel. We got tons and tons of videos here. There's probably got 90 plus hours of video now. Your next steps, if you haven't yet, by all means, please come take a free practice exam on our site. Right? You can also purchase the full 6, but you can always have the first one for free. And in fact, if you come onto our site, we have a ton of free resources, including taking any session 1 of a course for free. So you can attend any of our session 1s that you would like for free. Just go sign up online. Check out our free classes. Cool. All right, friends. Thank you so much for your time this lovely Sunday. Well, hopefully it's lovelier where you are than where I am. And again, I'm Whitney or Whit, either one. It has been a pleasure getting to hang out with you. And I hope that the rest of your studies go really well and that you come find us if you ever need anything else. Have a good rest of your evening. Take care and nice work tonight.